Okay, so let's look at question 9. Okay, please look at page 35. So this example is another position function, right? So we're gonna draw the how the particle moves along a straight line. Okay, so remember, if you want to draw something that moves in straight line, we did an example up here, right? And you can take a look at question 7, right? We use the horizontal axis as the position, right? And then label the time, okay? Time along each point, okay? So that's how you put it on a straight line. So let's do that, okay, for question 9. And at the same time, you can use this as a review, right? How to calculate cosine at trigonometry, right? Which you learn in grade 12, okay? So start by making a table of values. Okay, so we have the time is like the x, and then the position is s of t. Okay, and we want to graph the position on the time interval 0 to 5. So we'll graph every second, okay, just like last time. 0, 1, 2, 3, 4, 5. All right, so please plug it in. And you shouldn't be using calculator, okay? So try to do this, find the exact values, right? So plug it in and then find the answers. So for example, I show the first one, okay? So if I plug in 0, right? S of 0 will be negative cosine. Pi over 3 times 0 will be 0, right? Plus 3. And then cosine of 0, you think about the arm, right? Remember when you move, cosine 0, right? Sorry, this part. Cosine will be 0 on the top and bottom, 1 and negative 1, right? So cosine of 0 will be 1. So that gives you negative 1 plus 3, right? So I will have 2. So you are starting at position of 2. Okay? So please complete the table. When you finish the table, please raise your hand. Okay, we're gonna go over the values together. Okay, let's check answer for the first one. Okay, Jesse, what's your answer for t equal 1?
I had 2.5.
2.5. Okay.
Yeah.
Is there anyone doesn't know how to get the values?
For some of them, I don't know how.
Okay, which one are you on?
Well, for example, one, I didn't know how to get one.
Okay, so let's go over that one, right? Because this involves the grade 12, right? What you learn in trig. So we plug in 1, right? So you will have negative cosine. Pi over 3 times 1 will be pi over 3 plus 3. So now if you want to find cosine pi over 3, you need to first draw the angle out, right? Pi over 3, which quadrant does it stop in, Leon?
Quadrant 1, I believe.
Yeah, okay, it's a 60-degree, right?
Yeah.
Yeah, okay, so we draw that, right? So that will be pi over 3. And then for the pi over 3, we have special angles,
Oh, right.
right? How long is the opposite side?
Square root of 3.
Yeah, if it's a 60-degree, it will be the longer number, the bigger number. And then the other two numbers, how long is the hypotenuse?
I might have forgot.
Hypotenuse will be 2. And then adjacent, what's the last number? Do you remember?
Square root of 1 or 2?
1.
Oh, 1.
Yeah, okay, so you have to go back and check the grade 12. So now cosine pi over 3, what would that equal?
1 over 2.
Yeah, 1 over 2. Okay, so you plug it in, right? It will become negative 1 over 2 plus 3. That's how you got to.
Oh, okay.
Okay, so each number you plug it in, you can draw a picture, okay, find the exact value. Okay, it's a good exercise to review your grade 12 stuff. Okay. Okay, Karen, what's your answer for t equals 2?
I got 3.5.
3.5, okay. And Emily, what about t equals 3?
I have 4.
4, okay. Please raise your hand if you finish the whole table. So Leon, are you doing okay?
Yeah, I'm just trying to do the math right now.
Which number are you on?
I'm still doing 4.
Okay, so when you finish 4, can you tell me your answer?
Sure. I'm kind of lost now.
Okay, can you tell me how to write it out? Negative cosine and then what?
Bracket 4 pi over 3.
Mm-hmm.
Bracket plus 3.
Yeah, okay, so we're gonna work on 4 pi over 3, right?
Yeah.
Okay, so 4 pi over 3, which quadrant is it?
Third quadrant.
Yeah, so the picture will look like that, right?
Yeah.
So what's the reference angle there?
60 degrees.
Still 60, right? So the opposite side will be,
Square root 3.
yeah, still root 3, 1, and 2, right?
Yeah.
Okay, so what is the answer for cosine 4 pi over 3 then?
Negative 1 over 2.
Yeah, but we have negative times negative 1 over 2 plus 3, correct?
Oh, so it would be 3/2.
Yeah, okay, so 3.5. So you can start to see that there's a pattern now, right? There's a symmetry happening. So Joan, what's the last one?
I got 2.5.
Yep, okay, so you can see that it kind of like parabola, right? Because cosine graph is has symmetry as well, right? So let's graph it out, right? So follow the same way that we graphed last time, right? The horizontally. So you start from the horizontal axis is the position, okay? And by looking at the position, the biggest is only up to 4, so we don't need too many numbers, right? So we can have 0, 1, 2, 3, 4. All right, so please graph the points and connect them. Once you're finished, please raise your hand. So S of 0 is at 2. So the object starts at 2. So you put a point there and label t equals 0. Okay. If you finish the graph, please raise your hand. Okay, and this shouldn't take too much time. One is 2.5, 2 is 3.5, 4, right? 3 second is 4. Right? You can show the turnaround, so you can draw the point a little bit higher, right? Okay. So t equal 1, t equal 2, right? And then t equals 3. And then it's gonna turn around t equal 4. And t equal 5. So we'll go to the right and turn around. Okay, so that's how you can show it on the straight line. Okay, show how it moves. So you can see that the object is speeding up, right? Within the 1 second, right? Between each dot is always 1 second apart. So the first second, right, only travel 0.5, and then it travels longer. So that means it's speeding up, and then it slows down, right? And then it starts to speed up again. Okay, so that you can look at the distance and tell whether the object is speeding up or slowing down. Okay, so let's look at the next question. Now we got a graph, right? So we have to differentiate the two terms here. One is the displacement, one is the total distance traveled, okay? So make sure you got these two clarified, right? Displacement, what's the definition? How do we find displacement over this interval?
The final like position minus the initial one.
Yeah, very good. So you just focus on the beginning and the final, right? So in this formula, you can write it as position of t final, right? Minus the position of the t initial. Okay, there could be other symbols, right? So you could use this one or use other ones. And then you subtract the time, right? T final minus T initial. F for final, I for initial. right? So let's box that. So if I want to calculate, it will be, what's the final position here? 2.5.
2.5.
Yep. Okay, so right there, right? And then here. So we only focus on the 2 green spot, right? From there to there. That's called the displacement. How much position you changed compared to the beginning. So, oh, actually I made a mistake. Displacement doesn't need to divide, right? You just need to subtract. Okay, I'm talking about something else. All right, so let's subtract. So you will get 5 minus 0. Okay, and then second thing is the distance. So distance, you have to look at all the path that you traveled. Okay, so that means I want to include everything along the red line, not just the beginning spot and the final spot, right? So you can see from the graph, it turns around at t equal to 4. So there are 2 pieces of distance that you need to cover, right? So one is, because it turns around, okay, let's write that down. Turns or change direction, okay? Change direction at t equal to 4. So that means you need to first find the distance from t equals 0. Sorry, not t equals 4. T equals 3. Right? 4 is the position, right? So you need to find the distance traveled in the first 3 seconds, and then the distance traveled in the last 2 seconds. Okay, so it will be s of the position at 3 minus the position of 0. So that will give you the distance between 0 to 3 seconds. And because it's distance, we must keep it positive. So we put an absolute value. Okay. And then second part is you take the position at 5 minus the position at 3. Okay. So that's talking about this part.
Jason, shouldn't the displacement be 2.5 minus 2?
Displacement. Yeah, 2.
Yeah, that's what I thought too.
Okay, okay. Thank you, Jeffy. Okay. 2.5 minus 2. You are right. Okay. So here is 2.5. Right. Okay. Very good. So S of 3 will be 4, right? So 4 minus 2, right? And then S of 5 is 2.5 minus 4. Okay, so you always take the final minus initial, but then because of absolute value, it will make it positive, right? So 4 minus 2 is 2, so it travels 2 units. And 2.5 minus 4 is negative 1.5. Make it positive, so 1.5. So that will give you a distance of 3.5. Okay, so that's the second one. So this is distance. Okay. So remember, displacement, you don't care about what's happening in the middle, right? Distance, you have to think about where it changed direction and then break it into pieces. So if it changes direction again, you have to do another segment, right? So it's better to draw it out and see where you need to break apart.
Wait, Jason, why is for displacement ST initial 0?
Which part?
Wait, yeah, isn't displacement 0.5? Sorry, I wrote down 0.5.
5 minus 2
Yeah.
is 0.5.
Yeah.
Where are you looking at?
Displacement?
Displacement, yeah, and then why is it 2.5?
Like
it's
the
2.5
ST
minus.
initial.
Yeah.
2.5 minus 2. So it should
Oh,
be
-2, minus
Yeah.
2. Yeah. Okay. I'm still sleepy.
That's what I meant, but I didn't want to correct you a second time.
Oh, please, you gotta correct me. Otherwise, everyone's wrong, right? Okay. You're the only one awake now. Okay, 2.5 minus 2, 0.5. Okay, so you are only differ by 0.5 in position, right? So that's correct now. Okay. Any other mistakes? Okay, so displacement 0.5, this distance is 3.5. Let's look at next one now. So velocity, average velocity. So usually they use the symbol V and then write a little AVG. Okay, if there's only V, we call that instantaneous. That's last week, right? Instantaneous. Okay, so that's talking about the slope of tangent. Okay, you had homework on that. Now average velocity, because it's talking about average, so we don't care about the what's happening in the middle. So we will be using the displacement over the time. Okay, which if you see the formula, it looks like change of the position over change of time, right? Or sometimes, right, if you write in detail, it will be position of the final, right? I'm borrowing the symbol from the top, right? Over T final minus T initial. Okay, but I prefer just to use the middle one. Okay, I think that's enough. Okay. So remember, it's the displacement over time. So in this example, it will be displacement, okay, we got 0.5, right? Over the time. What's the time interval? Anybody? What should we divide?
5 seconds.
Yeah, 5 seconds, right? Because it's saying 0 to 5, okay? So the intervals here, it tells you the initial time and the final time. Okay, you start with 0 seconds, ends with 5 seconds. They could start from different number, right? It could be between 2 to 5, right? So if we divide that, it will be 0.1. And we don't have units here, right? So we just write 0.1. Okay, now the next one, the average speed. So remember, speed, it doesn't care about directions. So you have to include all the direction that you've traveled. You think of it like it's traveling in a straight line, right? As you are driving, right? You could be making a lot of turns. So when you calculate the average speed, you include all the distance that you travel. So we are not using displacement, right? Instead of displacement, it will be distance over time, okay? And there's no special symbol for this, right? So we just write it in words. So it'll be distance over time. Okay, so in this example, it will be 3.5 over 5 seconds, which is 0.7. Okay, so these ones are just names, right, which you need to be clear. So it's not really difficult, but later on when we use calculus, well, this part doesn't need calculus, right? Yeah, so just need to be clear with what the meaning for it, right? So one is average speed, okay? And then the other one is the average velocity. All right, so that's the end of the application, okay? So that wraps up last time. Okay, last time we went over velocity, right? Instantaneous velocity, average speed, and then today we add in distance and displacement. Any questions? Okay, no questions. We're gonna move on to graphing derivative function. And before we do that, okay, I want to use something we learned before, okay, to help you understand the next part. So when we were learning about derivative as a function, right? This is on page 31, right? You could turn to that page or look at the screen. We started with a parabola, right? And then you end up with a new function, which we call that derivative, right? Because we derive a new function, which is 2x. And because they are both functions, that means we can graph it out, right? So original is x squared, and then the derived function is 2x, okay? So let's see how they are related on the graph. So over here, I'm going to add a page. Let's see. So let's say we can copy this on at the corner of the page, right? From an empty space. So for example, original is x squared. Right? And then we have the parabola. Okay? And then after derived, we derive a new function, which is 2x, right? After using the limits. And how do we graph this one? What's the graph look like for 2x?
Linear?
Yeah, linear, right? This one has a positive slope of 2, right? So I'm gonna graph that. So something like this. So the meaning of the y here is different, right? On the left side, the red one is just the regular y, right? And x. Now for the right side, the vertical axis is the y prime and the x. So you are graphing the slope. Each of the vertical value is the slope for the green, okay? The left side is just points. So what that means is, for example, if I pick a point on the left side, okay? Let's say here I put it at the origin here, right? If I try to place a tangent line over there, then it should be flat, right? Because tangent line means it touches the point at one point. So the slope for that green line is 0. So that's why you have a point here on the right side at 0. Okay, now as I move to the right side, a bit more to the right, let's say over here, okay, on the red graph now. And if I place the tangent line, looks like that. So what do you think the slope of that line looks like? Can you approximate? Carrie, what do you think? What's the slope of the second tangent line? It looks, is it a positive slope or a negative slope?
Positive slope.
Yeah, so what do you think that slope looks like? What value, approximately? Make a guess. There's correct.
3x,
Huh?
3x.
The number, it's a number. Give me a
Oh, like the slope? Like,
slope.
oh, okay. So
Yeah.
3.
3, okay?
Yeah.
So, okay. So you can think of it as it's going up 3, right? Up 1, 2, 3, and then right 1. Okay. Well, it's not really that steep here, right? if I will be choosing, probably it looks like 1.5 or something, or 2, okay? But anyway, you said 3, that's okay, right? So at least you're not saying it's negative. So we go to the right side, at the same place, it will be at 3. So 1, 2, 3, okay? So you have a point there. So you are using the slope as the vertical value on the green graph. Okay? I'll repeat that one more time. Okay? On the red one, you are drawing the slope at different points. Right? You find the slope at different points and then use those slope as the vertical value on the derivative graph, on the green one. Okay, so for example, if I go to the left side, right, I pick another point on the left. So Jesse, what do you think the slope for this line now is?
Then that would be -3.
Yeah, okay, because it's symmetry, right? So on the left side, equally down, right, at -3, you will be plotting a point. Okay, so that's why the graph looks like, the green graph looks like a straight line. So every point on the left side, their slope becomes the vertical value for the derivative graph. Okay, so every point on the green, right? All these green dots, they all represent slope of each of the red dot over there. Understand? Okay, so they are both function, but their meaning of the vertical line is different. Okay, so keep this idea in mind. We're gonna graph derivative functions. Okay, so we are going to try to graph this one. They will give you the original and you want to graph the derivative. Okay, so let's look at question part C, right? We've learned that the derivative function calculates the slope of tangent line at different value of x of the original function, right? Derivative function finds slope of original. So therefore, we can say the derivative function, which is this, is derived from f of x, right? So its derivative graph can also be derived from the original. Okay, so let's look at each graph one by one. Okay, I'll show you question A. We'll work this through together, and then you can try question B. Okay, so we go from left to right, one section at a time, right? So here we have a straight line. I'm talking about, I'm gonna draw over it, right? This red line here. So can you tell me what's the slope of this red line? Jeffy?
Sorry, that's kind of loud. Is that -1?
Looks like -1, right? You can do find the slope by counting, right? It goes left 1, up 1, left 1, up 1, right? Or you can say down 1, right 1, down 1, right 1, okay? So you just use counting, then you can find the slope. So the slope for this red is -1. So I'm going to draw, right? So we are using the vertical one as y prime, okay? So all the vertical value are slope. So it'll be -1 is the slope. And then it will stay as -1 slope until this point. But then at this corner here, right? Because that's a pointy part. And at that point, there's many ways to draw the slope, right? Because it ends there. Or you can think of it, if I want to find tangent line. The tangent could look like this, right? Could look like that, right? Could be flat, right? There are multiple ways to draw a line to touch that point. So that means at that point, you cannot find a single slope for that single point. So at that turning place, we draw an empty circle. okay, it's showing that there is no derivative there. Okay, derivative means slope, right? So you cannot find a single slope for that. But for other points, right, the slope is the same, always -1. Okay? Any questions so far? How we get the green line? And we move on to the next red one, okay? The next one is here. So what is the slope of that one, Leon?
+1.
Okay, can you draw on the screen? Where should we draw the line then? Yeah, okay. Almost, pretty close, okay? 99% correct. So in fact, you're missing, what are you missing then?
Oh wait, is there supposed to be a circle on the Y line?
Yeah, very good, okay? Because
Oh yeah,
also it meets a corner, right? Remember whenever you
right.
corner, you cannot have a single value for slope, right? So you get that one, okay? Now the next red, it goes down. So the slope for that one will be what, Nicole?
Wait, can you repeat that? I glitched out.
What's the slope for the third red line?
Is it -1?
Negative what?
Uh,
What?
negative
Negative
1?
1, yeah, okay. So it will go down here, empty circle as well. And then until this bending point, okay? And then last line will be here, okay? What is the slope of that one now? Emily?
2/3.
2/3, yeah, okay. So you can do the counting, right? Write 3, up 2, right? You can use that. So you just pick 2 points and then graph and then count. So 2/3 will be somewhere here, and then it goes all the way to here. Okay, so the green lines represent the slope value for all the slope on the red. Okay, calculates the slope of the red graph, shows the slopes. Okay, so now I would like you to try B, okay? The straight lines are easier to do, okay? The curvy ones will work a few, and then I'll let you try it by yourself. Okay, when you finish B, please raise your hand. Jesse, have you finished the whole page?
No, there's some where I'm like kind of confused, and there's some where I'm like kind of lazy. I don't want to calculate it.
Okay, which one? Which one?
So there's like part of it like I don't really IHD. I'm kind of confused as to like with the curvy part.
IHD?
D.
Okay,
Yeah, IHD.
okay. Yep, yep, okay. Then you wait for us. Okay, also one thing to mention here, if the graph, it reaches to the end and to the edge of the graph, then you assume it's going on forever, okay? If it doesn't, right, then it will stop there, okay? It ends there. So that means your green graph, your slope graph, you should also make an arrow, okay? It means goes on forever. So the question B, right? The graph doesn't go on forever, so it actually stops at the ends here. Okay.
Jason,
Yep.
is H like? Do we have to do the circle formula?
Circle from no, you don't. We are just sketching. So
Oh,
it
okay.
doesn't have to be very accurate, but as long as the direction is close, then you will get a mark.
Okay.
Please raise your hand if you have finished the graph. Okay, so let's have Alex. Can you draw it on the screen? Show me what you got. Okay, thank you, Lex. Anybody wants to that has different? Any part that's different? Does everybody get the same graph? Check every segment.
Wait.
Yeah.
For
Oops.
the one in the middle,
Uh-huh.
I got like in between -1 and 1, I got -2.
Yeah. Okay. Hold on. I kind of lost it. 1.5 here, and then here. Yeah. Okay. So over here, let's graph it out. Right. The first segment is 1.5. Right. So that part is fine. Right. You need empty circle on both ends. Right. And then it will be flat. Flat means slope is 0. Okay. So far that's all good. It's the third segment, right? It goes down for right 2. So slope should be -2. So it should be down here. Okay, Lex? Yeah? Okay, and the next one is 1. Okay, so it'll be up here and then -1. Okay, so only the third segment, okay, is a bit too high. Okay, so let's go to next one. Okay, so next graph. Okay, so now we have a curvy one, right? So for the curved ones, usually we need something that's easy to find, right? Because it changes. That means the tangent line, okay, I will draw tangent with the red now instead, okay? So for example, I could have a tangent here and tangent there, right? Tangent, tangent, right? All these are tangent lines, and then it change. So we are graphing the slopes of each of the red, right? Each estimating, right? Approximating just by looking at the direction and then see the value of the slope, okay? So the most easy place to start is to find where it equals to 0, which means where is the slope 0, okay? Which place do we have slope equal to 0? Anyone?
Wait, what?
Where on the graph has the slope equal to 0?
Oh, at 0.
Yeah, at 0, right? The one right in the center. So
Yeah.
that will be the place we can start. Okay, so we can plot a point there. And then from there, we look at the little red segments. All those are tangent. So think about, are they positive or negative? Jeffy? On the right side, are the slope positive or negative?
They're positive.
Okay, yeah. And are the slope getting flatter or steeper?
They're getting steeper.
Getting steeper, yeah. Okay, so it starts with pretty flat and get steeper and steeper. So they are positive and steeper. So we are just gonna follow that and then draw the sketch. So that's how you don't need, because you don't have the value, right? You don't know exactly what they are. So you are just drawing the sketch of the shape, okay? So we can go up like that. Okay, so the green graph is showing that the red line is getting steeper as we move to the right side, and it's positive value. Okay, now for the left side. So first question is to ask, are the slope positive or negative? Joan, on the left side, are they positive slope or negative slope?
Like the point, the curve.
The slope of the red lines on the left side.
It would be
This part.
positive.
All those are positive still, right?
Yeah.
Yeah, even though they are underneath, the graph is underneath, but we are thinking about the value of slope. Okay, so don't get carried away by don't get confused by where the graph is, right? You have to think about the value of the slope because it's still going in the positive directions. So we still have to go up, okay? And as we go to the left, are they getting more or less steep? Leon?
More steep.
Yeah, okay. So that means we need to go more positive as we draw the graph. So go up like that. Okay, so the green graph is f prime. Okay, and then the black one is the f of x, the original. Okay, you are just sketching the direction, okay, where the slope will go, right, to show the pattern. Okay, you don't need to know exact value, but you only need to know exact value if it's a straight line, right, which you can calculate, right? If it's curvy one, you just think about the trend, right, how the slope is changing as we move to the left, move to the right, but you should start with a 0 first, right, because 0 is a fixed point, something you know exactly. Okay, so that's how you approach the curvy ones. So I'd like you to think about D, okay? So everybody try to draw something, even if it's wrong, right? We can learn from the mistake. And then once everybody got something on the graph, don't leave it blank, okay? Draw something on it and raise your hand, okay? I would like to see what you have. The left section is like a quarter of a circle, right? The circumference of a quarter of circle. Middle one is straight line, so that's the easy part. And then right side is another quarter of a circle. Okay, Jeffy, can you show us what you have?
I'm definitely not sure if it's right though.
Yeah, I'm sure other people feel the same. Okay, so no worries. Okay, just draw on the screen.
Oh wait, my ink is white. Do you know how I can change that?
You're what?
Like the color I'm drawing in, it's coming out as white. Do you know what? How I can-
How do you do that?
Oh wait, no, I got it. I got it.
Yeah, you can change the format.
Yeah. I I'll make this as straight as possible.
Yeah, that's good.
This is the part I don't know.
Okay.
Downwards. And I have it ending here.
Mhm.
On this side, I have it also going downwards. Ending somewhere here. Oh, that's a
Okay. Yeah. So by looking at the graph, right, we can learn like because when you are working on your own, you need to know how to check if it makes sense or not, right? So that's why even if you make a mistake, you can also learn from it. Okay. So of course the middle one, I think everybody should get it, right? This one has a slope of what? What's the slope? I use 1,
7
2,
over
4, 5, 6, 7, 7/4. So 1 point something, right? Yeah, so middle one is fine, right? So middle one is over here. So let's see why the other two parts, it doesn't make sense, right? So the way you can do is think about the slope. Let's talk about the right side first, okay? The right curvy one. You make slopes here on the original one. Okay, I'm gonna use blue, okay, so you can see. Okay, so I'm going to draw blue lines. So for example, I draw a line here. That's a slope, that's a tangent, right? If I draw another tangent, right? Draw another tangent, right? All these are tangent line, all the little thin blue line, they are tangents. So looking at those blue lines, do you think those slope are positive or negative, Jeffy?
I thought they were negative.
Yes, yeah, because it's going, yeah, the direction is going from top left to bottom right, right? So it should be negative. So even starting at the corner, it's already negative, right? If it's really, really close to the corner, it should be flat because it's like the top of the circle, right? So your beginning place, it should be at 0 because
Oh,
flat means no slope. Make sense?
okay.
Yeah, and then it will start to get negative, right? Start to get maybe a slope of negative 0.5, and then 0.8, and then 1, and then 2, right? Getting steeper and steeper, but in the negative direction. Okay, so that means it will go downwards, right? And then once it reached to the very tip, the slope become a vertical line. And it's so steep that you cannot measure it. So it's an infinite. So this side will go to infinity. So actually over here, it's asymptote, okay? Because you cannot measure the slope of a vertical line. Make sense, Jeffy?
Yeah. So
Yeah.
it's the same for the other side then, because
Yeah,
it's
the
also
other side will be similar, right? So I'll let you fix your graph on your sheet and then you can try on the screen, okay? Try to fix the left side. So what you can do to help yourself understand is to draw little line segment of slope. Okay. Yeah. Yeah. So if you look at the lines again, right? This will be 0, right? And then start to get steeper, but then they are all negative. Okay, so it's still going downwards. Okay, so you're correct, Jeffy. Yeah, so it goes start from 0 and goes down. And remember to draw the vertical asymptote line. Okay, to show that it never stop. Okay. Okay, so let's try another curvy ones. Okay, so if you get the answer for E, please raise your hand.
Wait, Jason?
Yep, Jesse.
Okay, I'm kind of confused now. Oh
Wait.
wait, never mind.
Sure.
Yeah.
Okay. Okay, anyone has question about D, let me know. Okay. If you finish E, please raise your hand. Emily, Leon, Nicole, any questions?
I'm just drawing.
Okay.
Wait, are we just doing E or doing H
Yeah,
and
you
I?
can finish E early. We can move on to F. Okay. Nicole, can I see yours? Could you show it on the screen? Okay. Does that, and is there anybody having different graph? Joan, what do you have? Do you have the same or different?
I have one that looks pretty much the same.
Pretty much the same. Okay, Jeffy, how about you?
I have the exact same thing.
Okay, Leon?
Yeah.
Yeah, okay, very good. Yeah, this is correct. Okay, so the first piece has a slope of 1, right? So make it flat. And what you can do is you pick a point to start, right? For the right side, you can say, okay, let's draw the slope here. That looks like a negative, and it's getting less negative, right? And then getting more flat. Flat means closer to 0, but still negative, right? And as we approach to the middle, right, it gets more negative and more steep. Okay, so you can look at how it changed for the blue line. Okay, and then we can graph that. So start from here, right, and then goes closer to 0, right? But then they are all negative value, more and more negative. So you also get an asymptote. Okay, let's go to F. So we are going to speed up things, okay? So how about you try draw the last, let me see, four graphs, okay? Let's finish the 4 graphs together, okay? All at the same time. And then when you finish all 4, please raise your hand, okay?
Jason,
Yeah.
for h, like the two ends, the slope is like negative.
Mm-hmm. And it will be vertical because it's like the end of the
Yeah.
ellipse.
But then if I take a derivative of the actual function,
Mm-hmm.
then like how does that work?
So at the end point, it shouldn't have any slope, right? Because it stops there, but it's as it goes very close to the end, it will be very vertical, right? It will become very steep.
Oh, okay.
Yeah. So it's similar to question D, right?
Yeah. Okay. Thank you.
Everyone has to try, okay? Draw something on the graph. I'll pick 4 people to show your answers, okay? But everyone has to finish. Draw something, okay? Anyone has trouble, like doesn't know how to begin at all? When you start, you can start by finding where it's 0, right? Where the slope is 0 first. And then from there, think about going to the right, going to the left. Is it getting steeper or less steeper? Right? Is it positive slope? Is it negative slope? Okay, then that will tell you the directions. And if the original is straight lines, then your derivative will be straight line as well, right? If it's a curved one, the derivative will also be a curved one. Unless it's like a problem, okay? Sometimes it will be straight line too. Okay, please raise your hand if you finished the 4 graphs. Okay, Emily and Leon, which question are you on?
I still need to finish like
half of a few.
Half of a few. What do you mean? H and I?
No, like I was jumping around.
Oh,
But I'm almost done.
okay, okay. Right. Let's start with F first. Okay. Let's see. Carrie, can you draw F?
Okay, but like I think my answer is wrong though.
No worries. Okay. We'll see you. What's wrong then? And John, can you draw G?
Yep.
Okay. Carrie, your drawing is not showing. I don't see anything. Oh, now I see it. Okay. It's coming up. And Leon, can you draw H? And next, can you do I? Okay, is there anyone wants to add in your input? Like, do you get something different?
I got something slightly different from F, but that's the one I'm most unsure about.
Okay, can you choose a different color to
Okay.
draw it out?
Wait, Jason?
Yeah.
Okay, so I'm like kind of confused because you know how you can like separate the function, right?
Separate the function. What do you mean?
Like oh wait, maybe I can't. No, I was looking at F, like can I like cut it in half?
Which one? F?
Yeah, like can I oh wait, I can't really separate. Never mind.
Okay. For F, there shouldn't be any empty circle, right? Because empty circle means you are not able to put a single tangent line there, right? Empty
Oh,
circle means you cannot prime, right? Cannot find the slope there.
okay, whoops.
So that will happen when you have a corner, right? Something that bends weirdly or something that stops, right, at the end, right? Then you cannot have a single slope. Okay, any other people want to add in your graph, like who got different? F, G, H, I. Nicole, are you, sorry, Lex, are you done drawing? Oh, you're still drawing, right? Okay. Lex, you have so many empty circle. Why is that? Empty circle means there's no tangent point there, right? You cannot put tangent line. So how's everybody else doing, right? Did you guys all get the same graph?
Right, I didn't really know how to do F.
Okay.
Wait, Jason,
Yeah, Carrie?
can I change my answer?
Of course.
The other line should be Jeffy's. So
Yeah,
like
right.
other red one pointing down.
Yeah, the red one is Jeffy. Yeah, so you can draw you are using brown, right?
Yeah,
Yeah.
but I got like the same line like for the right one.
Mm-hmm. Okay, yeah, you can just draw on top of it.
Okay.
Yeah. So Lex, you finished?
Yeah, I'm really unsure about this. So
Okay.
this
Yeah.
is what
Okay. Mm-hmm. Yeah, question I, anybody want to add in your answers? I don't think you guys all get the same graph, right? No?
Wait, for I
Yeah? Do you want to try?
don't want to try because I don't really know what I'm doing. But
Try
all
to see.
one like the thing I had different was like the point where it like kind of started,
Mm-hmm.
like it all started at 0 because the slope at like the point the like wait, I'm gonna try and draw it.
Yeah, draw it, then easier to talk about.
So they all kind of like started at the 0, like
Mm-hmm.
like kind of like this.
Mm-hmm.
Like this one also. I didn't really know what the slope of the thing was, or you
Yeah.
know what I mean, but like it kind of, and then or something like that. I don't really like know what I did, but like they all kind of start at 0, where like
Yeah.
the points
But
were.
you got too many empty circle though.
Oh, okay. Well, they weren't empty then. Oh,
Okay.
I don't. Okay, see, I don't really know what I'm doing,
Okay,
but
that's all
like, sure, you can color them in.
right.
Yeah, I'll
Okay.
color them in.
Okay. Yeah,
But
that's
like, yeah, just the stuff I had kind of at 0,
yeah.
because the slope there is 0, so it should start at 0. I don't know.
Okay. Carrie, you finished?
Yeah, I'm good.
Okay, so let's go over F. Okay, so maybe doing F, then you guys can learn how to do I as well, right? So it feels like F and I is the hardest one. Okay, so if you want to do F, right, like I said, you always find a place that is slope of 0 first. Will be easier to start, right? At least you have a concrete point, right? So where is the point that has a slope of 0? For question F, we are doing F first.
X equals to -5. Is that
Yeah,
5?
1, 2, 3, 4, 5. Yeah. Okay. So let's let me. I'm going to draw the slope, the tangent for that point, right? So it'll be flat like that. Okay. And then so that means at that place, I will have slope of 0. So I need to put a dot there. Okay. I'm drawing with green. All right. And then using that as a starting point, I start to move the tangent line towards to the left. Okay, I'll do the left side first. So the more left, what happened to the tangent? Is it getting positive or negative?
Negative.
Those are negative, right?
Yeah.
So it will be more and more negative. It will become steeper, right? So on the left side, it will go down. Okay, so that's that part. Okay, and then now is there another place that is also slope of 0?
X equals to -1.
Yes. Okay, so I will put the tangent line there, right? The hill, right? And then that means over there you get another 0. So somehow it should connect the two dots, right? The 2, 0, they should connect. So now I start from the left side of the 0, I have tangent line. Now these are positive tangent lines, right? It becomes the steepest somewhere in the middle and then become less steep. As we go to the right side, okay? So the graph will continue to go up, right? But it has to go to a place where it's the steepest and then starts to get less steep and then connect. Okay? And then after that 0, it will become negative. Oops.
Hey, Jason,
Yep.
how do I know where to end the steepest thing?
You don't know. Just that's why we are only checking the directions.
Oh, okay.
Yeah, just approximate, right? You can say, okay, that feels like slope of 2 at the steepest. So you can go up to 2.
Okay.
Yeah. So for example, I can go up to 2 here and go down. And then it will become negative slope all the way down. Okay, so that will be the graph for the first one.
Wait, so all of these are like approximate though, right? Like
Yeah,
you don't know exactly where it is.
Yeah.
Okay.
Okay, so the green one will be the slope, right? So you can check the 2 dots where I started first, right? The 2 green dots, that's the 0 slope. And use that as the center. You think about the left side as negative, right side is positive, right? And then move from there. Okay, question G is okay, right? G, we have two graphs here. Yeah, the first piece should be negative. Okay, so negative, what's that? Negative 0 point something. Yeah, so it should be here. Okay, Joan, you did this one, right?
Yeah.
Yeah, okay, so first piece should be negative, so it should be underneath. And then
Yeah.
the rest are okay, yeah. Okay, let me erase that. Okay, now the H is good. Okay, very good, Leon. Yeah, so any question about H? Anyone wants to ask why? Okay, so let's clear that. H. Because it's a vertical asymptote, right? Because the slope will be vertical line. Middle is 0. And then it gets more and more positive. Right side, it gets more and more negative. Vertical asymptote. Okay, so now last one. Last one is similar, right? Kind of combination of question F and question G, right? You have the straight line part and the curvy line. Okay, so I would like you to try to fix it on your own first. Okay, and we'll try again. Okay, if you finish question I, please raise your hand. Okay. So sometimes the question they will ask you to do the matching, right? They will give you one graph that's F, one graph that is prime, want you to match which one match which one. Then that, in that case, you don't need to draw, right? You just need to make sure the directions are correct. But if they do ask you to draw, right, they won't be marking the exact points. They are just checking if you got the directions correct, right? Instead of open up, you draw open down, then that would be wrong, right? Okay, please fix your question I and raise your hand. Okay, Emily, can you try this one? Can you show question I on the screen now?
Okay, I really don't know if this is right. How do I?
You
Oh,
understand
here we go.
F,
Okay.
right? Do you understand F?
Yeah, I do, but okay, well, whatever, we'll see.
Yeah, we'll see.
Okay, green should be fine, right?
Yeah.
That's supposed to be connected, sorry.
Okay, let's see it.
And probably, sorry, that's way too high. Just. I think.
Okay, yeah, not too bad. Anyone wants to smooth it out? The same. Yeah. Okay, let's start with 0 place, right? The place where you get flat will be here. So that will be my starting place, right? The slope there is flat, right? And then another flat place will be here. So I get another 0 down here. So far she got those 2 places right. And then as we move to the left side of the first 0, it will be more negative. So it bends down. Okay, try to make it more smooth. And then the middle part, right? The steepest will be somewhere in the middle between the 2 straight lines at 2 points. So it will be the highest and then bends down, right? Become less positive, right? It will become positive, but more and more positive and become less positive. And then goes to negative side, right? All these are slope are negative slope. So it goes down and to some place, then it become a corner. So it's empty circle. Okay, she's got it right. And then finally, the last one has a slope of 2 point something, maybe, right? 6/2, I think. What, 5/2, so 2.5, right? So it'll be over here. Okay, so that should be the graph for the final one. Any question here? Okay, if no question, let's take a break. Okay, after the break, I'll see you at 6:45. Okay.
Okay.
Yeah, see you soon.